Please excuse me for the delay. So the principle of transmissibility, what it states is, if the line of action of the force is the same, okay, the result what is desired will be the same. So here when I explained you all this 10 kilonewton force, once it was acting from the left side, of the box. In the second case, that same force came from the right side. So what happened here is, this caused the rightward movement of the box, and in the next case, as the line of action was maintained the same and the intensity of the force was also the same, only the action was changed from push to pull, the same result was obtained. This is what is the principle of transmissibility of the forces. Now, for example, if you want to move a car which is not working, okay, if you want to move a car which is not working, what you generally do, you push from behind. Okay, you push from behind so that the car moves ahead. But if it is still not working, what you do, you call a crane. What does a crane do? From where the crane will take the car, from front or back? Siddharth Pattar,
Front.
are you there? Yeah, front.
Yes, sir.
Okay, Siddharth. Yeah.
Yes,
So
sir.
what will be the difference if you are pushing the car and if the crane comes in and acts? What is the difference?
So there is no difference. The force, the line of force is same.
Same, yes. But only the thing is that your action when you are trying to move the car is a push, whereas that crane will push the car or pull the car.
Pull the car.
Yeah, crane will pull the car. At the end, the result is what? Car is moving. Okay, at the end, the result is what? Car is moving. Because what happened in both the cases, the line of action of the force was kept same, and the desired result, that was the motion of the car, was obtained. So instead of 3, 4 people pushing a car, a single force, that is a crane, could pull the car very much easily. So after that, we come to the next principle, that is principle of superposition of forces. This principle is also very easy and very easily understandable. It states that the net effect of a system of forces on a body is equal to the combined effect of individual forces acting on the body. Now see again the statement. The net effect of a system of forces acting on a body is equal to the combined effect of individual forces acting on a body. The net effect of a system of forces on a body remains the same even if the system of forces in equilibrium is added or subtracted from it. Now there are two things in this superposition concept. So we'll go to the example first, which will make you the things clear. Then again we'll come back to the definition. So again, same thing. We have a floor on which we have the boxes kept. Now we have a force 10 Newton, 20 Newton, 30 Newton. Okay. So now all these three forces are trying to push the box. Okay, the total force is 60, 30 plus 20 plus 10, 60. When these forces are applied, what happens? The box will move towards the right side. So now, in next case, I'm taking the same box, but I'm applying now a single force. Okay, the 60 is a combination of 30 plus 20 plus 10. What did that 60 kilonewton force do? It pushed the box towards the right side. Now I'm replacing those three forces with a single force, that is 60 kilonewton. And what happens? The result is the same. The result is the same. So what does the definition tell us? The net effect of a system of forces on a body is equal to the combined effect of individual forces acting on the body. So net effect of system of forces means, net means it was the total. That is 10 plus 20 plus 30. So 10 plus 20 plus 30, individually three forces were acting. Now next what I did, the box moved towards the right side as desired. But in the next case, instead of applying three forces, I took the combined effect. Okay, instead of applying all the three forces, I took the combined effect. Combined effect was again 30 plus 20 is 50 plus 10 is 60. So instead of applying individual 111 force, what I did, I took a single force of 60 Newton, and I found that the result was again the same. So this is what is the meaning of the principle. First part of the definition, that is what it is. Okay, what is that? The net effect of a system of forces. Now system of forces means many forces, 30, 20 and 10, that made the system. The net effect of on the body was the box was moving towards the right side. Then what I did in the next case, I combined the forces. Okay, I combined the forces into an individual force, and that individual force also was made to act on the same body. Okay, so this was the first case where there is a system of force. We have three forces acting on the body, and those together are pushing the body towards the right side. So in the next case, what I did, instead of taking a system, I took one individual force which has the same effect, and I found out that they are doing the same work. Okay, they are doing the same work. So this is what is the principle of superposition. So it's asked in the exam regularly. I'll share this definition. So remember this principle of superposition. Now the second part is net effect of a system of forces on a body remains same even if a system of forces in equilibrium is added or subtracted from it. Now in this sentence, what is important here is even if this part, okay, this part is very important. Net system of equilibrium is added or subtracted. Let's better see it with the example so things will become clear. So again you have a box. So you have that system of force, 30, 20 and 10. Now in this case, box will move towards the right side. But now I'll apply the definition of superposition. I apply 5 kilonewton force, and here also I apply 5 kilonewton force. So now with this, Amruta, what you feel, what will happen? Amruta? Vijayalakshmi Patil, are you there? Vijayalakshmi? Vijayalakshmi, are you there? Not able to hear? You can on the mic. It's fine if you're not in the proper range, it's okay. No problem, no issues. Pritam, are you there? Pritam?
Yes, sir.
Yeah, now what do you think what will happen? This phi and phi, will it have an effect?
Sir, the body will move in right direction.
Yeah, right direction only, but that phi and phi which I have showed in the color, red color, will that have any effect on the body?
No, sir.
No, why it will not have any effect?
Sir, because the net force is more on the left side.
No, the thing is that phi in red color on the other side will cancel each other. Those two forces are in equilibrium.
Opposite in direction.
Yeah, opposite in direction. So that's the point here. Thank you, Pritam. So now the point here to understand this from the definition is, in first case, the box was there and we had three forces, 10, 20 and 30. So box will move in the right side as you all rightly said. Now what I'm doing, I'm introducing one equilibrium system. Now what do you mean by equilibrium? Equal and opposite. The system remains constant. So I am applying 1 5 kilonewton force from left side also, and I'm applying 1 5 kilonewton force from right side also. So when we go to count the net effect, what is happening? 30 plus 20 plus 10, that is our 50 Newton is as it is. But that 5 and 5 which was added later will cancel out each other, because that 5 and 5 is what system? It is a system in equilibrium. Okay, so the second part of the definition of superposition of forces tells us that same thing. What does it tell? The net effect of a system of forces on a body, the net effect of system of forces on a body remains the same even if a system of forces in equilibrium. So in my example, which was the system of forces in equilibrium, 5 Newton and 5 Newton, one was acting towards right side, one was acting towards left side. So if you apply a system of force which is in equilibrium, the net action remains the same as it is. It won't change. Okay, the net action remains the same as it is. It won't change. So there are two ways in which we have principle of superposition. One is it gives the net effect. Again, I am telling. So here what is happening? We are applying three forces, 30 plus 20 plus 10, that is 60, and the box is moving towards the right side. So in the next case, what I'm doing, instead of applying three forces, I'm replacing them by a single force, which has the same magnitude. So what will happen here? Again, the box will move in the right side only. This is the first part of definition of superposition. Now, in second part of the definition, what I have, again, I have the same box on which I'm applying the same forces. But now what I'm doing is, now this will give the same effect. Box will move towards right side. Now I'll add one more 5 Newton force. Now if I keep it like this only, the box will move faster because now the force has become 30 plus 20 plus 10 was 60 plus 5, it has become 65. But what I'm doing, I'm applying one more 5 Newton force from the other side. Now in this scenario, what is happening is this 5 Newton force and this 5 Newton force, these together form an equilibrium, means equal and opposite. So this force is acting towards the right side, pushing the box towards right side. This is pushing the box towards left side. So what happens? They cancel out each other. Okay, their effect will not be into picture because they'll cancel out each other. And only the action will be of this three forces or the system of three forces. This is what the definition of superposition says. If forces are applied on a body, and then again if you apply one system of equilibrium, here phi and phi is an equilibrium force, and you apply that, this phi and phi will not have any effect because as they are in equilibrium, they will tend to cancel out each other. So this is what is principle of superposition, or two parts of principle of superposition. So now where this will help you all is in mechanical actions, or say if you're designing a ramp, all those things, these all concepts will be useful further when you go to application part of your engineering, means when you go in the field. So the last concept which we got to discuss is principle of physical independence of forces. The principle of physical independence of forces. So what does this principle say? It states that the effect of a force acting on a body is independent of the effect of other forces acting on the body. Okay, what does this principle say? The effect of forces acting on the body is independent of the effect of other forces acting on the body. This principle clearly highlights that each force acts independently. Presence or absence of any other force does not have any impact on it. Okay, so the name itself says the principle of physical independence. Physical independence means action of each and every force is independent of the other. So even if other force is existing or not existing, it doesn't matter. Okay, the force which is there, it will be there. It is not dependent. Okay, the total work done might change depending on the number of forces available, but each and every single force will have its own effect. That is what is the principle of physical independence of forces. Now again, for example, if we take the box, the 10 kilonewton force is there. Then we have the 20 kilonewton force, and we have the 30 kilonewton force. When all these three are applied, the box is pushed towards the right hand side. and in the second case, I have a 10 kilonewton force. So now what is happening is 10 kilonewton force also, if it is applied independently, it will also push the box. Okay, it will also do its work. But what will be the thing is the box will move a bit slowly as compared to the previous thing, because in previous cases, and it may not reach the end. Okay, it may not reach the end. Okay, so see here what is happening when I'm applying a single force. It is doing its work. The box is moving, but I wanted to push the box outside, which was there in the previous case. Okay, so now when I come to this case, what's the scenario? 30 plus 20 plus 10. So this 60 Newton total force is able to push the box outside completely. Now in the second case, what I have done? I have taken a 10 kilonewton force only, or 10 Newton force only. So it may not be capable, so we don't know, but it is an individual force, and when we see it is doing some work. Okay, so when 10 plus 20 plus 30 was there, 60 Newton, the box was able to go outside. But when I removed the other forces and only applied which force? A single 10 Newton force, what I found? Still the box is moving. Okay, definitely the box is not going out because this 10 Newton force may not be capable of doing that. But still it is doing its part of the work. Okay, it is still doing its part of the work, which is important. And that is what is the principle of independence of forces. What does this principle say? Every force has its origin and every force is capable of doing some of the other work. Okay, even if you have a combined system of forces, if other forces leave, if that single force is remaining, it will do its part of work. Maybe what is to be achieved may be achieved or no, that is secondary, but it will do compulsorily its part of work, because force when applied has to do work. Okay, so I took this example for it. We have a box wherein we are applying three forces, 10, 20 and 30. That is totally 60 Newton. And those three forces combined together, what are they able to do? They are able to push the box outside. So now I want to check out only if I apply 10 Newton force, what will happen? So I take the floor, again I take that box. And now in this case, what I do is I apply only 10 Newton force. And in this, what I find, the 10 Newton force is also doing some work. Okay, but it is not able to do the work of the level of the 60 Newton force combinedly, but still 10 Newton force has its own independence and it is doing its part of the job. Okay, this is what is the principle of independence of forces. So now in today's class, we have discussed majorly the three important principles, that is principle of physical independence of forces, superposition and transmissibility. So these three principles are very important from practical point of view because it is directly related with the application of force, and you need to understand these principles very much properly. So now once again, briefly, we'll check out what's remaining in this module. We have covered basic concepts of idealization, that is particle, continuum, and rigid body. In today's class, we have discussed basic principles, that is physical independence of forces, superposition, and transmissibility. Then we have discussed in yesterday's class Newton's laws. Okay, so now with this, what remains is force and force system, which we'll be covering in the next lecture. So now today itself after the class, up to here, I'll be sending you all the list of questions and all the PDFs of these presentations so that you can make the set of notes and keep. So once you get all those PDFs and with the questions, see that in a proper notebook. Okay, in a proper notebook, you write those question and answers. So further, I'll consider that only as an assignment. Even if it is not there in the assignment book, it will be fine. I'll consider that only as the assignment. So just briefly, let us round off today's class with the discussion. I'd like any one of you all to explain me one principle. Amruta, Konsagar, Amruta.
Yes, sir.
Yeah, can you tell me what was the principle of transmissibility which we discussed?
Principle of superposition.
Okay, you want to superposition? Okay, tell that. What was principle of superposition?
The net effect of a system of forces on a body is equal to combined effect of individual forces.
Forces. Okay, can you give one example for it?
Uh,
Any silly, simple example will do. Okay, fine, Amruta. Thank you. I'll ask someone else the example. Okay, thank you, Amruta, for your answer. Santosh, are you there? Santosh, are you there?
Yes, sir.
Yeah, she explained the principle of superposition. Can you give an example for principle of superposition?
Applying combined
Yeah. Now, for
10.
example, Santosh, you have a younger brother, sister. Okay, they are trying to lift something. Okay, which is quite heavy. And somehow they are able to lift it. Then what you will do? You will tell them, "Sari re, na kortini nimge anda." You will go, you will lift that thing and keep it where it is want. So what does that happen? That is principle of superposition. Here you are the single force. And which force you are replacing? The combined force applied by smaller younger brothers and sisters you are replacing. That is what is principle of superposition. Means it says that a system of forces can be replaced by a single force and same work can be done. Okay, fine, Santosh. Swati Hiremat, are you there? Swati?
Yes, sir.
Yeah, principle of transmissibility. What does it say? Principle of transmissibility, what it says?
When many forces are applied on a object, it can be replaced by a single force.
It was again superposition. So, who will like to explain this? Is any one of you? Prerna, are you there? Prerna? Yeah, we are discussing something. Will you explain me? Principle of transmissibility. Okay, the statement is there on the screen. Okay, now I'll change that figure. I'll keep that box figure. 10 kilonewton force is applied. This will push the box towards right side. Now what will happen in the second case? Second figure, if you remember, where I'll apply this 10 force. Where I'll apply this 10 Newton force. Is anyone of you
Right
present
side,
can tell me?
right
Yeah,
side,
right
Front
side.
of the
right side, yeah.
Yeah, from means this was which force? Now this was a push. I'll replace this push with which force?
Pulling
pull.
force.
Pulling force, right. Whenever a
Pulling.
force comes inside, it is a push. Whenever the arrow is outside, it is a pull. So now in second case, what I'm doing, I'm applying the same force. But only the important thing here is line of action of both should be the same. Okay, line of action of both forces should be very, very much same. So now what happens in this case? The action will remain same. Okay, so this is the second principle. So now the third one was principle of physical independence. Okay, third one was principle of physical independence. Chetan, are you there? Chetan, Avdi, Chetan. So these all will go as absent, huh? Who are not responding will go as absent. Vidyashri, Vidyashri, are you there? Bhavya, are you there?
Yes, sir.
Yeah. Can you tell me the last one, physical independence?
So basically, if there's a number of forces acting on a body,
Yeah.
each single force will have its own way, own influence on the object.
Exactly. Very nice. Yes, correctly you have told it. So what does this principle say? This principle is very important because it tells us that each and every force available has to be respected. Okay, each and every force will do its own job. Okay, something or the other each force will do. Okay, so that is what is your principle of superposition. So this is the physical independence. Sorry, yeah, you have correctly told that each and every force will have its same part. It may do the desired work or no, that we don't know, but it will do its own part. So this was the example. 10, 20, 30 is combined together. This was able to push the box outside. But when we applied a single force of 10, it was not able to push the box outside, but it did its own part of the job. This is what is the principle of physical independence of the forces. Okay, so I will wind up today's class a bit early as we have to go to the next concept, which we will be discussing in the next class. So next class will be very important because from that basics we'll be going ahead to solve the problems. So I request all of you all to put your name and USN for attendance, and then you can log out of the meeting. Thank you all. See you in the next class. Have a good day.